Today we'll look at pressure and forces in the context of a fluid. So pressure is defined as the magnitude of the force perpendicular to a surface on the cross-sectional area. And in standard international units, we use newtons for forces and meters squared for area. So the pressure is in newtons per meter squared, and when we define it as such, 1 newton per square meter is 1 pascal. And similar to newtons and kilonewtons, 1 kilopascal is 1000 pascals, and 1 megapascal is 1,000,000 pascals. So for example, suppose we have water in a rigid container and we look at some object submerged in the water. So what we have is some block. So therefore the fluid exerts contact forces on the block in all directions. So on all surfaces of the block we're going to get perpendicular forces which increase with the depth, as we'll see when we look at hydrostatic pressures. So basically at a given height below the water, so effectively that perpendicular force is the resultant of the uniform distribution of pressure on the top surface of the block. And basically if we look at the right wall of the container, well, the pressure is going to increase as we go deeper into the fluid, because there's going to be a higher mass of fluid pushing on the container wall, and this pressure is going to act effectively on that perpendicular surface of the container going into the screen, as you can imagine. So we also have air on top of the water, so we have a pressure due to the atmosphere, which we call the atmospheric pressure, and the pressure in 1 atmosphere is equal to 101.3 kilopascals. So effectively fluids are really exerting a contact force on an object, and the pressure is a distribution of force on the object. Now if we look at another example of forces related to fluids, so if we have the block floating on the surface of the fluid, well, what we have is the force of weight pushing down on a block, and we also have a force Fb, which is the buoyant force pushing up against gravity to cause that object to float. And of course if we look at this block's also going to have a force of weight acting downwards. And remember that when we have the specific gravity of a material less than 1, then the object comprising that material is going to float, and if the specific gravity is greater than 1, then the object's going to sink in the fluid. Let's look at another example. So if we have a car, that's traveling along a road surface, so the car is going to be subjected to wind forces which are going to have a complex flow around the car. And typically if we're not looking at the rotation of the car, well, we model it as a particle, and that distribution of wind pressure we model as a drag force, and we also have friction between the tyres and the road, so we also have a friction force opposing the motion of the car, and we also have a force of weight pushing the car downwards, and a normal force due to the contact of the tyres on the road, so keeping that car from sinking into the ground. And as you saw from your mechanics course, the acceleration must be in the direction of the net force. So effectively the car is decelerating or slowing down in this case. So if you took a sum of forces in the horizontal direction, we have the mass of the car times the acceleration. So what we have in this case is the friction force plus the drag force acting in the same direction as the acceleration of the car. So this is Newton's second law. Now if we take a sum of forces in the vertical direction, well, the net force acting on the car is 0 in the vertical direction. So in this case we have the force of weight acting downwards plus the normal force is equal to 0, because there's no acceleration in the vertical direction. So that's Newton's first law. Okay, so this here is Newton's second law, and this here is Newton's first law. And let's look at an example of Newton's third law. So effectively what we're going to have is the road pushing on that left-hand tire. So this is the normal force due to the road on the tire. And if we look at a free body off the road, well, what we have is a normal force due to the tire on the road. So by Newton's third law, if we have object 1, which is the road in this case, exerting a force on object 2, which is the tire, well, effectively object 2 is going to exert an equal and opposite force on object 1. And that's Newton's third law. So every action has an opposite reaction. And I'll see you in the next video.